Hello viewers, my name is Naveen. I am working as Assistant Professor of Physics in Nagarjuna Government College, Autonomous Nalgonda. This video is the first video of the series of videos to be posted by myself. These are aimed at helping the students of Nagarjuna Government College, Autonomous Nalgonda to go through their academics during this pandemic. This is the beginning of 2020-21 academic year. This is the first video I am sharing with you students. And my topic, the paper which I am going to deal with within this semester is electromagnetism. Actually, for both third semester as well as fifth semesters, you both will have this paper as for this semester, because from 2020-21 academic year onwards there is a change in the CBCS syllabus pattern, because in this semester both third semester students as well as fifth semester students will have this paper electromagnetism. Before going into the topic, I just want to recall some facts and some information, some contents which are learned by you during your plus 2. In today's video, I am going to just remind you those topics, and you can prepare well for the by the next video, in which I am going to start the syllabus. Okay. Talking about fifth semester students, for the last 4 semester, the syllabus is like this. In the first 2 semesters, you gone through about motion of your body, that is mechanics as well as waves and oscillations. In your third semester, you dealt with thermal physics, which is a form of energy, that is heat, about heat and all those that energy form you gone through in your third semester. And in your fourth semester, you studied optics, which is another form of energy. Basically, physics is the study of matter and energy. That is why the syllabus is divided like this. If you come across third semester students, they gone through mechanics in their first semester, that is again motion of the body, that is studying about a matter. And in your second semester itself, you gone through about a heat, the energy form heat. Now in this semester, we are going to see some other energy forms, that is electricity as well as magnetism. These both, for centuries together, physicists thought electricity and magnetism as 2 separate branches. But later on, it came to know that they are interlinked together. That is why a new branch of physics came into picture in the last century, that is electromagnetism. For the last 200 years, electromagnetism is being treated as a separate branch which deals with both electricity as well as magnetism, the relation between electricity and magnetism. And now in this chapter, in this first chapter of our syllabus, we are going to study about electrostatics. Electrostatics, that means if a charge is at rest, we are studying about the properties as well as the phenomena around a static charge. That is, this chapter is named as electrostatics. Okay, before entering into this electrostatics, I just want to give a brief picture of charge and the basic concepts. Okay, first thing I just wanted to talk about composition of matter. In this video, I am going to talk about composition of matter, and then what is charge, how charge can be created, not created, but how charge is of 2 types, what are the properties of charge, and Coulomb's law of electrostatics, because it is a primitive one you gone through in your plus 2 level. Even in school level also, gone through about Coulomb's law of electrostatics. You are familiar with that. I just want to remind that Coulomb law of electrostatics, and then concept of electric field. There we are actually our syllabus is starting. Okay, composition of matter. We all know matter is of three states: solid, liquid, and gaseous. Any matter is among these three classification. So if we go on dividing matter, we see molecules as the component particles of matter. Every molecule is, again, if we go on divided, we see atoms. Atoms combiningly form molecules, and molecules forms matter. If you see atomic structure, we find elementary particles as a fundament, or also we call it as fundamental particles, which can't be further divided. Molecules divided into atoms, atoms divided into elementary particles. But we cannot divide the elementary particles beyond that. Okay, these electrons, protons, neutrons, about this you study in atomic structure. What there we say nucleus is there in every atom. In nucleus we find protons and neutrons. Around surrounding nucleus there will be orbits. In orbits electrons will be revolving, and we say electrons will have negative charge, protons will have positive charge. That is the fundamental point where we study about charge. This is in this image you can see a atom. The center in the nucleus we find protons and neutrons. That is neutrons are shown in red color balls. Okay, protons and neutrons combine together in the nucleus. They are tightly bound with nuclear forces. Surrounding to the nucleus, electrons are revolving in orbits. These electrons, by some means, if they gain energy, depending on the configuration of the atom and depending on the force with which it is bound, these electrons can come out of the atom. If they are excited, they will come out of the atom. What happens if an electron comes out of the, generally every atom is neutral. Every atom is neutral because the number of protons is equal to the number of electrons in the atom. It is known as atomic number. It is denoted by Z. If an electron comes out of an atom, then the number of protons in the atom becomes more and the number of electrons will be reduced by 1. If one electron comes out, number of electrons will be reduced by 1 in comparison to the number of protons. So this atom is known as positively charged. This atom is known as positively charged. If this electron is attached to some other atom, neutral atom, then there the number of electrons is increasing, so that atom becomes negatively charged ion. We call it as ion. But now it is ion. This is a chemical term, but in our case we say this as positive charge, that as negative charge. This is where charge comes. Okay, here it is written in this slide, every atom is neutral. If it loses electron, becomes positive. If it gains electron, becomes negative. This is the primary and fundamental concept about charge. There are different ways to charge an object. Here generally we always, when starting electricity, any book, they will give the example of friction, rubbing of comb with hair. When you comb your hair, then after combing, if small pieces of paper are bring at the comb, they will be attracted towards comb, because due to the friction between your hair and comb, one is positively charged, another one is negatively charged. There will be electron transition between your hair and comb. So both gets charged, and they attract papers, because charged object attracts neutral one or opposite charge. Okay, so this is the why this example is always given is this is the case where existence of charge was first discovered by earlier scientists. They give many examples: rubbing of glass rod with silk cloth, or ebonite rod with cotton cloth, or combing example like this. Apart from friction, certain other methods also there for electrification. But it is first thing where electricity, the existence of charge was discovered. That is why we give this example. Okay, now it is clear. Charge is there. What is positive charge? What is negative charge? At the atomic level, it is clear for us. Now, in electricity, we need to deal with charge. We need to deal with charge. So, we need to see what are the properties of this charge. These properties of charge are very fundamental to study about charge and its consequences, or its properties, phenomena happening around these charges. What happens if the charge is at rest? What happens if the charge is moved? All those things comes under next parts. Okay, in this chapter, electrostatics means it revolves around static charge. When charge is at stationary, what happens around the charge? What are the phenomena observed around a static charge? That is electrostatics. Before going into those phenomena, we need to understand what are the basic properties of charge. The first one is charge is a scalar quantity. It will not have any direction. It has polarity, positive charge, negative charge. It is polarity, it is not direction. There is no direction for charge. Charge is scalar quantity, and the charge is measured in coulombs. Unit for charge is coulomb, denoted by C. Okay, I didn't mention all these things because they are very fundamental. You need to go through them once before going into our next video. That is why I am reminding these topics. Okay, the next property shown here is also very familiar to you. That is, there are two types of charges: positive charge and negative charge. Positive charges, similar charges repel, and opposite charges attract. This is also known to you. And you see the fourth property of charge. Charge is quantized. What is the term quantized? Charge is quantized. It is an important property of charge. We need to know about quantization of charge. It is an important term, quantized. Quantized means everything. For example, the number of human beings in your classroom, the number of students in your classroom is quantized with 1. I say like that. The number of students in your classroom is quantized. That is, if I ask someone of you to count the number of students attended in your class, you will say and count, say 60 or 61. But nobody will say 60.2. 60.3 members are present, sir. Nobody will give answer like that, because the human being number is quantized with 1. Either 1 is there or 2 is there, but 1.2, 1.3, 1.4 humans will not exist. That is, it is quantized with 1. Wherever you come across this term quantized, it has that similar meaning. Here, charge is quantized with what? With the charge of an electron. Electron is the fundamental particle. In our earlier slide, we discussed this. Electron is fundamental particle. It can't be divided. It can't be divided further. So electron is fundamental. Electron charge is also fundamental. You see any charge in the universe, wherever charge is there, definitely that is a multiple of an integer multiple of electron charge. If electron charge is denoted by small e, any charge Q is equal to plus or minus Ne. You see, plus or minus, because positive charge is there, negative charge is there. If an atom loses electron, it becomes positive. If an atom gains electron, it becomes negative. So the charge, the existence of charge itself in the number of electrons. So Ne, I am saying Ne, n number of electrons, plus or minus, either positive or negative. That is, the charge is quantized with the charge of electron. The charge of electron is 1.6025 into 10 to the power of minus 19 coulomb. This also, you should remember this constant also. This is another property of charge, it is quantized. Next, charge is conserved. Conserved means the charge neither be created nor destroyed. We cannot create charge on our own. Anywhere we cannot create charge in the universe. In earlier cases, in the friction of glass rod or silk cloth, both becoming charging. One is positive charge, another one is negatively charged, because the electrons from one object are moving to other objects. So suppose 8 electrons are lost by one object, the same number of electrons are gained by this object. So this is positively charged, this is negatively charged. Both objects, one is positively charged, one is negatively charged. But the total number of electrons in the universe always remains constant. That is charge conservation. This is one more property of charge. Okay, once again I am summing up the properties of charge. One important point I need to mention here. Charge is, first point, charge is scalar quantity. Charge is scalar quantity. Suppose in a screen, suppose in a paper, suppose you have a point charge here, a point charge here, a point charge here, static charges. Suppose n charges are there. What is the total charge on this sheet? If I ask you like you simply add all the numbers. Suppose here plus 2 coulomb, here minus 1 coulomb, here plus 3, here plus 10, here minus 15, like that. Then no need of going around how much distance is there, or what is the direction between the line joining these two charges and these two charges. This is not required, because charge is a scalar quantity. So simply the algebraic sum of all the point charges in this sheet gives total charge on this sheet. That is the importance of remaining this scalar quantity, charge as scalar quantity. Okay, after that, this is a famous law, Coulomb's law of electrostatics. Coulomb's law of electrostatics. You may come across Coulomb's law twice in your +2 level. One in electrostatics, another one in magnetism. Okay, that is why here we are mentioning clearly Coulomb's law of electrostatics. This law is about if 2 point charges, let us say they are Q1 and Q2. Q1 and Q2 are 2 point charges. They are separated by a distance, or they are separated by a distance r between them. I am not saying the charge of the polarity of Q1 and Q2, which one is positive, one is negative. I am not saying anything. Q1, Q2 are 2 point charges. There is a distance of r between these 2 point charges. Then the magnitude of the force between, electrostatic force between these 2 point charges is inversely proportional to the square of the distance between these 2 charges, and it is also directly proportional to the product of these 2 charges. That is Coulomb's law of electrostatics. Here in this equation you see Q1, Q2 in the numerator, that is F is proportional to Q1 into Q2. F is inversely proportional to, it is mentioned in the definition, F is inversely proportional to square of the distance between them. So F is proportional to 1 by r square. So we put together those two statements, we get F is proportional to Q1 Q2 by r square. Upon examining the force between different set of charges, Coulomb derived the proportionality constant as 1 by 4 pi epsilon. So he combined these two, he come across the equation 1 by 4 pi epsilon Q1 Q2 by r square. This is the force of, in other words, we can say like this. This is the force of attraction or repulsion between 2 point charges separated by a distance of r. This is about magnitude. What is the direction? The direction is along the line joining these two charges. Here we are talking about direction because force is a vector quantity. Force is a vector quantity, charges are scalar quantity. So the force of attraction or repulsion between two charges separated by a distance r is inversely proportional to the square of the distance between those two charges and directly proportional to the product of these two charges, and the direction is along the line joining these two charges. This is a very fundamental law of electrostatics. In our first chapter, majorly we are going to, depending on this force law, we are going to give definition for electrostatic field strength. We are going to derive potential. We are going to derive capacitance. All those things are derived from this law. So I just wanted to remind you in this first video itself about this Coulomb's law of electrostatics. What I require from you students to attend, to do before attending the next video is to go through about these fundamentals and to apply this Coulomb's law of electrostatics to derive force in different cases. In different cases, you try to derive and solve some problems based on this Coulomb's law of electrostatics. Then we will start our next class with the concept of electric field. Actually, electric field is also you've gone through in your lower level, but before we are discussing this electric field in a broader sense. Okay, you might have gone through about electric lines of force. In our next class, we will discuss about electric field strength, electric field, electric lines of force, their characteristic, electric flux. All those things will be discussed in our next video. Thank you.